Okay, well, yes, good afternoon to you. I hope you're enjoying the conference so far. I've really enjoyed listening to all the talks that we've had up to this point. Um, and this afternoon in our group, we're going to talk about adopting AI. So this is one of the less technical topics, I guess, in that my background is in change management and all around how do you bring the corporations that we might work for or want to work with, how do you bring them with you? And how do you encourage them to adopt your solutions and get the benefits out of them? Um, and this is just a discussion group, and I can see we've got sort of nearly 30 people or so on the line. So um, I'll I'll talk for 15 or 20 minutes to share some thoughts on the sorts of challenges and opportunities that I've seen in my travels in trying to deploy AI into water utilities. But as Casper said at the start, there'll be a chance for questions at the end, so we'd love to take questions or simply have some discussion between us where anyone, I invite you to share your experiences in how your own journeys have been and what sort of challenges you've come across and ways that you've been able to overcome them, because I think we'll all benefit from learning from one another while we're together. But to kick us off, I'll share some thoughts over the next 15 or 20 minutes or so. My name's Chris Thomas. I'm the Head of Innovation and Enterprise at Isle Utilities. Isle is an innovation and technology consultancy. So we try to work across the whole life cycle of innovation, whether that's with the investors up front who are searching for the next great technology that they can help bring to market, or whether it is with the technology companies themselves who are developing new products, helping them with their strategies to bring those products to different markets, or helping them with the features within their own product development roadmaps to make sure they are suitable for different use cases. And we also work with the end users, so the water utilities that adopt these technologies. And we'll be spending our time, I suppose, with this talk, thinking mostly around what that end of the journey looks like and how we can encourage perhaps the utilities we work with to adopt our solutions. So before we dive into the challenges and solutions to trying to adopt AI in our companies, I thought it would be worth thinking about why artificial intelligence is exciting, just quickly. And I suspect if you've joined this conference, I'm preaching to the converted. You've probably already signed up to this conference because you think AI is exciting, or at least you want to hear about it. But for those of us who have been working in this area for a while, I think we can get a bit tired sometimes of the hype that exists around artificial intelligence. There's an awful lot that gets said about it and promised by it, enough to fill several hot air balloons, I suspect. But I thought I would share my views on why I think it's exciting and what I've seen of it in the industry for the moment, and hopefully give a slightly new perspective, perhaps. And I think the first thing, before thinking about artificial intelligence, is just to think about the impact and purpose of digitalization and what it offers for water companies. And fundamentally for me, I think digitalization is all about the means of measuring something and then being able to optimize it because you measure it, and being quite efficient in how you do that, whether that's automatically or through some level of sophistication that new algorithms bring. And in that respect, digital, therefore, is applicable to almost anywhere in any industry. So we've seen a huge rise in adoption of digital solutions in all sorts of industries, and a huge rise in the sophistication that's there. But it's a very exciting area, not just in terms of what digital can do for companies, but it's exciting to investors as well, because digital as an area, if you compare it to physical products and hardware, for instance, is very attractive for investors. It's much easier to develop prototypes. It's much easier to scale them. And the economics around things like software as a service are very attractive. So it attracts a lot of investment as an area. And that's great because whether we like it or not, money does make a difference. And where there's money, lots of innovation can flow. And the water utility sector is not one that's known for leading the way. But what's exciting about digital is because it brings this wonderful growth area with strong investment behind it. I think as a sector, we're starting to witness new science appearing into the sector, a level of science that we've not always been used to or seen before. I think the trendy buzzword for it would be deep tech. And so I'm not talking about the science behind artificial intelligence algorithms and neural networks and the like. I'm thinking of the science here that's being developed in what we measure, so that we get more data sets that we can use and deploy and learn from. At ISLE, being an innovation consultancy, we see lots of clever technologies coming through. So three that I've worked with recently. One is a technology that points LiDAR cameras at treatment works, and it can use the quantum phenomenon of the gas coming off the treatment works to detect and identify what gas is there and how much is there, such that we can identify and measure greenhouse gases. And I can't pretend to be able to explain what's going on around those quantum phenomenon, but a level of science there that's very sophisticated is fantastic to see entering the water industry. Similarly, I spoke to another company recently that is using the very, very small changes in gravity to be able to scan beneath the ground and identify what's there and where there are voids and the like, to support with where companies might want to dig holes. And I had no idea that we could measure changes in gravity if we weren't sitting inside a lab within CERN or somewhere. So that was very exciting to come across. And again, lately, we've been closely working with a company that uses shock waves in water pipes, so not sound waves, but shock waves, so a bit different to what we've seen before, to identify where leaks are. And they're working on science that is very new. You know, at school or university, we might have been taught that water is incompressible, and they're working right at the forefront of their field, looking at how shock waves start to compress hydrogen bonds within water, and then looking at the behavior of that water thereafter to be able to identify and find leaks. And I think it has the potential to really revolutionize how we do acoustic monitoring and correlation in the identification of leaks. So all of this, I think, is very, very exciting for the sector. But as we get more sophisticated, we're able to bring in more and more data sets. And with lovely concepts like open data, offering data out to the world of data science, things get complicated very quickly. And the reason why artificial intelligence, I think, is exciting in this field is because it helps us to unlock some of that complexity. Where we might have previously been constrained to working out causal relationships and scientific relationships between every different variable and working out how they all interact, we can now use statistical analysis in a very meaningful way to navigate through that complexity. And it allows us to deploy things, therefore, much quicker than we might have done before, but also with a level of sophistication that we may never have reached before. And at a cost point that we might not have managed before. And all of that, I think, is very exciting for the industry. But with that lovely picture painted, you know, if it's all true, why aren't we seeing it absolutely everywhere? Why isn't it more pervasive? And if you've been involved in trying to deploy new solutions, whether they be artificial intelligence or any other, you'll know that it can be quite challenging in companies. And there are a number of challenges that we come up against. So I've tried to break down some of these challenges and explore what the solutions to them might be. It would be lovely afterwards to get some of your comments and thoughts on whether you agree with me or disagree with me, or whether you've had your own experiences of some of these areas and how you've overcome them, because I think it will be very beneficial for everybody. But here's a few that I've come up with in thinking about this topic. So the first challenge we have with artificial intelligence is one of trust. Um, and if we look at this first point around correlation versus causation, I think this is a real paradigm shift for many people within the companies that we work with. So utilities are generally full of very clever engineers who are familiar and used to working with scientific models with causal relationships within them, to give a very accurate understanding of what's going on. But moving to artificial intelligence and asking an individual to move away from perhaps a model they've used that's been based on physical equations and move to one that's based on statistics can be difficult, because famously, correlation is no sign of causation. That, of course, doesn't make it irrelevant, but just means it's a different way of looking at it and can lead to some challenges around trust. The other angle here, though, is how we deploy AI and what we like to use it for. So typically, we love to use it to make forecasts of what's going to happen next, which is great. It sounds very attractive to the management within water utilities and helping them make their decisions. But in reality, when you try to do it, it requires a high degree of trust. So, for example, imagine you are sitting in a control room and you are responsible for monitoring the sewer network, and you've been given a new system that can forecast pollution events on rising mains. And maybe it's clever enough to use weather data that's coming in, and it looks at the water levels around the pump that feeds the rising main, and perhaps a number of other variables. And the alarm goes off that says, oh, in the next few hours, we think there might be a pollution event about to occur. And you might therefore have to take some action to try and avoid it before it happens. So you might have to call someone up on overtime, at 2 a.m. in the morning, and you've got to wake them up, and you've got to use a bit of their team manager's overtime budget to call them out to an issue that hasn't actually yet happened. And so there's an awful lot of faith that has to have to be there within the corporation in order to be able to go ahead and get the most out of predictive solutions. So there's a big challenge there. The next challenge is data quality. This has come up a lot today, and I've no doubt that it comes up all the time in your line of work. I feel like there's a lot of corporate culture that surrounds data quality. It's the sort of topic that everybody loves to moan about. And whilst that can help with everybody feeling like they're part of the club, I think it can be quite damaging, because it can create a lot of perceptions about poor data quality that may be completely unjustified. There are very real struggles that people have in getting their data quality up to scratch. But I think because we like to talk about it culturally so much, I've often seen project proposals killed and stopped because the practitioners realize that it's going to need to use a particular data set that they think is absolute rubbish. And before you get any way into the feasibility of that project, you already kill it, because you know it's going to use a certain data set that has earned a certain reputation for being unreliable. Whether or not you've been able to test whether you can overcome some of those data gaps or whatever they might be. The other thing is being aware of how we build our models and whether we make them very sensitive to having very, very high quality levels of data. We've heard from a few people today how when you deploy into the real world, you get all sorts of funny things happening, whether that's with measured data and instruments with strange calibration requirements or going wrong in some way, or whether it's with observed data that comes back from human records. We do need to be aware that we've got to have some level of flex, either in the model or in how we deploy that model, so that we're not overly sensitive to data quality. The next challenge is around the business case. So sometimes actually deploying these solutions just can simply be too expensive. So if you are trying to purchase a solution that's made by a supplier, often they will use a SaaS model, so software as a service, that requires a monthly subscription or an annual subscription. And that puts it on OPEX budgets typically rather than capital budgets, which can be a bit of a pain, as OPEX budgets are often under strain in a way that capital budgets might not be. And there are ways around that, but similarly, sometimes it can just be too expensive compared to the value that it might immediately bring to a company, and so the pricing doesn't quite suit them. Alternatively, companies might be trying to insource their own solutions, so they might have invested in their own data science capability and look to build their own solutions. And I think that's always exciting to have within a company. It's great to see that happening. But quite typically, those teams are great at project delivery, but very often they haven't factored in all the post-deployment support that's required and the cost of servicing that software once it's out there to keep it loved, keep it used, keep it adopted, and make sure you're fixing bugs and dealing with change requests and the like. And then the final challenge that I thought through was simply the change management burden and recognizing that change is hard. When you deploy a new solution, AI or any other, it's not just that solution you're implementing, of course. You're going to affect the ways of working of potentially hundreds of people if it's a very wide deployment. So doing it at scale can be difficult, and we have to recognize that it can be hard for companies to move fast. But more than that, I've put in the second point around an anchoring bias. So this is a psychological bias that we all have as humans. And it's the bias that once we've invested in something, we like to keep investing in it, even if it's no good, because we've invested in it. And we have so much at stake, as it were, that it keeps pulling us back. And sometimes we need to be conscious that our decision makers might have this anchoring bias around legacy systems, particularly if they've had to invest into that system to build workarounds and keep it going and keep it propped up to provide value to the business. Or perhaps it's just familiarity that keeps them there. But we need to find ways of breaking that anchoring bias. So there are 4 challenges, and that's quite a bleak picture. So I'm going to try not to end there. I'm going to suggest a few ways that we can get around these challenges. As I say, I'll be very intrigued to see whether that resonates with people as we draw to the end of my talk here. So on the first point of trust, how can we get around this? Well, we did some work recently looking at the trends in machine learning and where people are going with how they use artificial intelligence. And one of the big trends that's happening is hybrid AI or constrained AI, where models ensure that variables relating to physical parameters are limited and constrained to only operating within the bounds that is physically possible. That sounds quite obvious in many respects, but it's an important feature, I think, in gaining trust in the model, such that if there are engineers who you're trying to bring on this journey of moving away from causal models into statistical models, I think that can be very helpful, and particularly in certain applications. For instance, in biological processes, I'm told, it's not an area I know a great deal about, but I'm told, bacteria will move from sort of one kinetic relationship to another set of kinetic behaviors, and they're very different. And you have to be able to recognize when those physical parameters change so that you can control for them and make sure your model is giving you reasonable outputs. Similarly, I think you can think about how you're deploying your pilots and your trials to prove your solutions. So quite often we will try and pilot a solution and we might compare it to historical performance and say, look, we've done better. Therefore, we should scale this up. And whilst that makes sense, it's quite easy for cynical people in the company to poke holes in that and find reasons why that pilot today was different to the historical scenarios you're comparing against. And that can slow things down and become troublesome. And so I would encourage everyone when designing those pilots to think about things like whether a control activity can be run in parallel to it that makes it much harder to poke holes in and find a skeptical viewpoint from. On the point of data quality, I think a really important step is around an investment in reporting and analytics as a company capability. This is because if you set up a team like this before you get into sophisticated machine learning and AI capabilities, you've created an organizational entity that owns the problem of data quality, and they will care about it, and they will want to make sure data is usable and that the data in core systems can be trusted. So they'll look to all the good practice around data management and data governance. And I remember implementing a team like this at a past company I worked for. And we spent a lot of time wrestling with how do you identify your data quality issue, but then notify the data owner in such a way that they will pay attention and not just fix it on a spreadsheet that they refer to, but fix it in the core system so that everybody who has access to that system can trust what's in there. And that's a really important piece. And that reporting and analytics capability will have to fight that process and cultural barrier to make sure data quality is as good as it can be before you deploy machine learning models on it. And then the other thing I think I'd want to say about data quality is that something is better than nothing. And we need to remember that. And you don't always need your model to be 99.99% correct, as long as it takes you forward in your decision making. And I think understanding where you can finish your modeling and let a business process take over can help you go a long way in not getting stuck around this problem of data quality, and just recognizing that sometimes even very poor data sets of poor quality can take you a long way forwards in your decision making. On the business case, on the cost point, sometimes the products on the market simply are too expensive, and it's very difficult to make the business case stack up. But it's quite useful to just take a step back sometimes when looking at your projects and think about where you're deploying them. And if you're deploying it into a very data-rich area, you might have sufficient data to be able to train your own algorithm rather than having to buy one off the shelf from a supplier who's been able to build up a mature model from lots of data sets. And it's not that you might build it yourself, but you might be able to get another supplier or a software house in to develop it for you. And quite often the cost of doing that can work out more competitive than buying it straight from a supplier sometimes. So there are alternative routes depending on the scenario you're looking at. On the points around companies who might have in-sourced capabilities and battle with that challenge of forgetting the whole life cost and the post-deployment support costs, I think this is a question of maturity. And so I've simply written keep going, because I think you have to bump into those issues, and I think you have to encounter them and you learn from them and adapt and grow as a mature capability on the organization. So there's no silver bullet there, just simple grit and determination to keep going and make sure that you can grow your capability and learn from some of those challenges that you might encounter on the way. And then around change management, a bit like the reporting and analytics thing, I think it's important that every company recognizes the need to invest in an internal capability around change management. And if you're looking to deploy machine learning models and artificial intelligence solutions, if your company doesn't have that capability, I would suggest that you should consider it alongside your own deployment capability and make sure you factor it in. And then finally, around this anchoring bias that we all have, and that we want to try and encourage out of our decision makers, I've put exposure. And what I mean by that is trying to ensure that we all expose ourselves to what's possible and what others are doing to make sure we don't anchor to our own scenarios too much. And that could look like belonging to technical working groups or local forums or research bodies, or attending conferences like this, of course. To make sure that we're all aware of what's out there and what's possible, and that we don't keep investing just due to unconscious bias in our existing systems because they're familiar and because we've spent a lot of money on them in the past. So there are the 4 challenges, my 4 suggestions about how we can solve them. I'll stop talking there, and I hope some of them have resonated or proved interesting to people. But I'd love to hear either your own questions on any of that, or your own encounters and difficulties in deploying within your companies or your clients, and how you might have overcome them. But I'll stop there. Thank you.
Hi, Chris. Maybe I can ask you a question.
Hi, yeah, lovely.
Hi, yeah. Very nice presentation, by the way, very thorough. And can you still move your slides? I guess, can you go to the previous slide? So very interesting when you mention like the business case, also like the way how, let's say, like a water company can implement like an AI solution. You were talking about sort of capital investment versus OpEx, right?
Yes.
So like software as a service versus some other type of solution. Can you please elaborate a little bit more there based on your experience, and whether, I don't know, because I know that ILE works in many different countries, whether you see that there are different, let's say, the utilities of different countries have a different approach to when it comes to the business case. Thank you so much.
Yeah. Okay. So on the OpEx versus CapEx piece, it's difficulty because I suspect people will recognise the challenge that utilities face in constantly wishing to reduce OpEx. From the sort of executive's point of view, OpEx is the overhead, in running the business, and the more that can be reduced, the better the value to customers. And capital budgets are not a bad thing, because capital means that you always end up with an asset, and therefore the valuation of your company is always going to be stronger than if you didn't have it. So there's a difference in how those two budgets are viewed, one a little bit more negatively than the other. And when it comes to OpEx, I think it's not always a problem to buy software from OpEx. More and more companies are doing it as SaaS becomes more and more pervasive and it's understood. But also people are being imaginative, I think, in how they try and avoid using OpEx budgets. So with suppliers who only provide SaaS solutions, often accounting guidelines within a company will say something like, if you have an asset that lasts more than 5 years, it can be considered on the capital budget as opposed to the OpEx budget. So if you can buy 5 years worth of subscription upfront, you can move it from your OpEx budget to your CapEx budget. So sometimes there's a sort of imaginative ways to try and make sure that you can capitalize things where possible and where feasible. I think the other thing I'd say about a CapEx budget is that it's associated with a bigger objective. So CapEx is there usually as part of an investment case to do something really specific, like reduce leakage, or reduce pollution events, or minimize CSO overflows, or whatever it might be. And there will be a lot of hardware that gets deployed, and you often need the enabling technology associated with that hardware. And by bundling the digital product alongside the hardware product that goes to fix a much larger solution, it can often be much easier to create that collective business case that makes sense, as opposed to simply taking the software solution on its own and trying to wedge it into an OpEx budget that always has a lot of tension and pressure on it anyway. So I think that dynamic of moving it into the capital world just opens up how you can build the value that a solution provides in a much more ready fashion than OpEx might be. With regards to different countries, I think it's worth recognizing that everybody's just in very different places, and there's obviously difference in regulated utilities versus public utilities, and there's difference in scale. So, if you look at the market like the US, there are so many utilities and they're so varied. Some are huge and some are absolutely tiny, and those tiny ones are not going to have the capacity to consider advanced digital solutions. So you're going to have to focus on the large utilities. And within Europe, you're going to have the difference, say, between the UK, where I live, where you've got regulated utilities, and many of the neighbouring companies where they're typically more public, and the different regimes change according to the kind of the local drivers. And one year it might be leakage, the next year it might be pollution events, and so it's quite hard to pick a consistent solution for long enough to develop some of the solutions you need. I don't know if that's quite answered the last part of your question. Do come back to me on that.
Yeah. Thank you so much. Maybe just a small comment. I don't know if you're familiar with let's say, the startup landscape. Going back to the first question, whether you see like new players, let's say, that might come up that are considering all the things that you say about the business case, like how to actually, because that's where sometimes the disruption occurs, right? You also come with a very nice let's say, creativity, as you were discussing, in terms of fitting the budget and so on and so forth. So, and also maybe providing the solution that you were talking about that were a little bit more encompassing to further justify maybe the expense. So just if you can briefly, if you have any idea about the new players in the market if they are doing this?
Yeah, actually, that's one of the areas of sort of digital and machine learning that I really love, because it's so much easier for startups to exist and get into the market quickly than with hardware products. But what it means for utilities is that they really need to think differently about how they engage with their supply chain, because typically utilities are used to buying assets that might last 25 years, meet all sorts of engineering thresholds from big companies who can demonstrate a lot of financial resilience and meet all sorts of procurement thresholds. But when it comes to digital, most of the innovation might well exist in the world of the startups who can't meet those procurement financial resilience metrics, who might be just more immature commercially. And actually, you're not really procuring when you're working with an entity like that. What you're trying to do is partner. And you're trying to partner with them and help them develop and help them grow and help them make sure their product is robust as well. And I think utilities need to recognize that they need to change mode from the traditional procurement approach to one of partnering with startups to help them and to help to help both sides of that arrangement, really. So I think there's a difference in approach, and you're seeing that with many of the more mature sort of innovation focused utilities that will do things like run accelerator schemes for startups, or run specific funding mechanisms and competitions and pitching events and the like. But there's a long way to go, I think, still in moving many utilities across into that slightly different way of operating and partnering with a different end of the supply chain.
Thank you so much.
If I may, I would maybe add to this.
Please do.
Well, first, thank you very much. And maybe just adding to the business case, I think we need to widen it a little bit in AI, ML, whatever it is focusing again on the old problem of cost and value. Because the business, you discussed the business case sort of within utilities being private or public. But for example, with our SEMA Plus deterioration model of sewage systems, you achieve a much higher degree of reliability, essentially, on data on how they deteriorate, hence on how to keep them in shape, and potentially saving millions in cities like this, Berlin, etc. But still, you're discussing about the cost of actually implementing it, and very little about the actual value delivered by it, which I think now utilizing tools like this and others we heard today are getting increasingly powerful. So I think the business case or the value case and business case needs to also be discussed with the actual asset owners behind that. And that sometimes is not the utilities. So of course they need to be on board. But I think that's something we experience quite often, actually.
Yeah, absolutely. Thanks for that. I totally agree. I'd be interested in if there are other challenges that people have come across that perhaps I've not picked up on, that anyone might want to share that they've struggled with, and we might well have some views on how they could be addressed potentially. Looks like perhaps I've covered the big ones. Are there any other final questions at all? I think we're due back in the main session at 5:05, so we've got time for a few more questions. Or if not, I suppose there's time to go and grab a coffee before the main session begins again. Are there any other final comments or questions?
I think Julius is trying to say something, but we cannot hear you, Julius. Maybe.
I perceive the question to be primarily between the public utilities commissions, the utilities, and private industry. It seems that there's not enough push from above for the actual change to take place. Most public utilities simply run on inertia. They are not very progressive. All they're doing is basically wait until the water appears at the surface and then patch.
Yeah, I think we'd definitely agree that there's a lot of inertia in the utilities. I think that does that sort of speaks to the anchoring bias piece, doesn't it? And there's a lot of safety in the utilities in being sort of local monopolies that doesn't always give them the same incentives to move that sort of a competitive market might do. So that is definitely a challenge. I know that the challenge doesn't always exist with just the utilities, though. I think it does exist sometimes in the supply chain, where often you get very, very adept and capable data scientists doing very sophisticated things, but they might not be as close to the use case of the utility. And sometimes you get a communication breakdown between the two, and they can't quite explain the value to one another. And I think sometimes with the sort of the busyness of everybody's days in these environments, I think that can slow things to a point where you don't always get the traction that some of these solutions deserve. And I think someone raised in one of the earlier calls the importance of having sort of hybrid staff who know an awful lot about the application within the water environment and an awful lot about machine learning and can be that medium to help it flow. So thanks. I think we'd probably all agree around the inertia that exists in the utility system, but I think we need to recognise also some of the challenges that go through to the other ends of that supply chain as well.
Well, I'm actually somewhat concerned that the lack of force from the various bureaus of weights and measures as far as consumer protection goes, because it seems that given the fact that we're talking about literally hundreds of millions of dollars per year of losses, I'm really quite concerned about the lack of attention to the water loss issue.
Yeah, absolutely, and I think that does vary from country to country, but water is certainly one of those tricky areas, isn't it? It's not like energy where it might be slightly easier to monetize. I think water is more of a sort of a human right than it is something that has value, and therefore sometimes I think there's something lost in valuing the importance of making sure that we pay a lot of attention to water loss because of the degradation it does to the environment, because of the impact that not coping with it well has on our assets and the life of them and the sort of the overhead of maintaining them. So I think there's something in the visibility that sometimes that gets lost in the value of water because it tends to be lower cost or treated as a right and sort of made almost freely available compared to other commodities that we're used to consuming. So I think that is a big challenge and a sector one that I think needs tackling on a topic beyond just artificial intelligence, really.
Well, I think
comments in the chat there, sort of adding to that, I think, around how different countries deal with it. In the UK, imposing large penalties on companies where they don't meet their targets.
Good, thank you.
Thank you, Arno. That's really appreciate your views. And I can see, Julius, it doesn't look like you've managed to come off onto your microphone, but I can see in the conversation you've mentioned the importance of governance as a topic, and actually it being a central design point in many of the data platforms. And I think that's great. And many solutions we see boast of their ability to help with managing data quality, which I think is really good. The important point from my point of view there is, once you've got that warning signal of a data quality issue, how do you resolve it? And how do you make sure it's resolved properly in a core system that the enterprise manages rather than getting done by a workaround that sort of perpetuates the problem? But it's really great to see our sort of ability to do that in an automatic fashion. Thanks, everybody.